So I'm also keeping the book open. So just to say that whether, so in the last class, we discussed about the brief structure of the periodic table. So imagine the periodic table is right behind me right now. So on the left hand side, what do you have? You have the metals for your understanding. That's group 1 and group 2. And then we start with group 3. Group 3 is also metal. Group 4 is metalloid. And then group 5, 6, 7. That's the metalloid to non-metal start. And then group 8 becomes the inert gases. Okay? Group 8 will become my inert gas. Now, for us to understand more is, we call them the main group. In Cambridge, what do we learn? We learn about main group elements. What are our main groups? So this is a key word you should mention. What are main group elements? All elements which are classified under group 1, 2, 3, and then 4, 5, 6, 7, 8, they are called my main group elements. They do not include transition element. Transition elements are the elements which are between, if you have your chemistry book, you can keep looking. Okay, otherwise, the transition elements are the elements which are between 2 and 3. Transition elements are the elements which are between group 2 and group 3. And these transition elements starts from period 4. Okay, this was one discussion that we had. Are you fine with now groups and periods? Groups are the vertical arrangement of elements and periods are the horizontal arrangement. Our periodic table has got 8 groups out here that we have seen, and it has 7 periods. Okay. Then we also spoke about something called valence electron. This is very important. Okay. From now, let me start writing valence electron, because this discussion will keep on coming. Electrons that are present in the outermost shell of an atom is called valence electron. Why is this electron important? Because these valence electrons participate in bond formation. They are the ones who are going to participate in bond formation. Like say sodium chloride. Let's say sodium chloride. Sodium is 281, and if you look at chlorine, then chlorine is 287. For me, this and this are important because these electrons are going to participate in the bond formation, right? Another thing that you should remember is that why do elements form bonds? Elements form bonds in order to obtain stability. What is the criteria for stability? How do you quantify? Well, stability is like becoming the nearest inert gas. In other words, we say that trying to copy the inert gas electronic configuration. Okay, next class, just these 2 classes, keep the textbook with you because it will help you if something is getting missed out. So sodium will like to become the nearest inert gas. Chlorine will like to become the nearest inert gas. So in order for that, they will form a bond between themselves. So in this chapter, we are not considered about bond. What we are concerned about is that these electrons will actually guide the property of chemical reactivity. Once you know these points, then you read from any book, your point should be clear. Look, I'll explain these points. They guide the property of chemical reactivity. Now let's understand. Suppose now look at me, I am sodium. How many electrons do I have on my outermost shell? 1 electron. Am I stable? No, you are not stable because there are only helium, neon, argon, krypton, xenon, radon. Only they are stable. The rest, no one is stable. So question comes, if I am unstable, then I am reactive. I am reactive. I will react with someone. Jagda karunga main kisi ke saath. Then the question comes, how much will you be reactive? That depends upon what is my tendency to get, this one will tell me a lot of things. What is my tendency to become stable? Well, my tendency is just lose 1 electron and I become stable. Zyada mehnat karna nahi hai. Like when you are standing in a big queue and many people say, ma'am, I have got 5 questions. Ma'am, I have 3 doubts. Somebody says, ma'am, I have just 1 punctuation doubt. He will be very reactive. But just okay, bol dijiye, comma lagega ki nahi, and then I'm out. Baki, gone. So this fellow says, I just need 1 electron to lose. If in its comparison, I have somebody else called say magnesium, and magnesium is say 282. Magnesium also wants to be stable, but it has to lose 2 electrons. Zyada kaam karna hai. Compared to this and this, its reactivity will be more. Obviously. Have you understood this logic or not? Why sodium's reactivity will be more? Sodium is more desperate. See, you want to be stable. Magnesium is also desperate to be stable. But the question is, who can quickly become stable? This one can quickly become stable because the job is to lose only one electron. So comparing in a metal to metal concept, if you compare on a metal to metal basis, sodium's reactivity is more than that of magnesium. And if I have aluminium out here or a boron has got 3 electrons in its outermost shell. वो भी stable बनना चाहता है पर उसको 3 electron खोना पड़ेगा. Either get a suitable partner who can take my 3 electrons, whatever it is. But in this case, so do you now understand that why the valence electrons are important? The valence electrons are going to tell me about chemical reactivity. And now if I look at chlorine, just look at chlorine. Chlorine also has 7 electrons, means it needs 1 more electron. So chlorine is equally going to be reactive. But there is a difference in the reactivity of both. While this is thirsty to have 1 electron, this is very desperate to lose 1 electron. Let us come one step behind chlorine. Let's look at oxygen. Oxygen is 8. So oxygen is what? 2, 6. Now oxygen needs 2 more electrons. Does oxygen not want to be stable? Yes. But oxygen ko 2 electron chahiye abhi bhi. So at this stage, children, just try to observe that the valence electron speaks a lot about the reactivity, the chemical reactivity. Okay. And looking at the valence electrons, we will be able to say what is the chemical reaction. Like I have, and when I compare two elements, I will not compare sodium with chlorine because this fellow is a non-metal, this fellow is a metal. I will compare this fellow with this fellow. Now tell me, between these two metals, who is more reactive? Sodium is more reactive. But question arises, if I see group 1 and I'll write from lithium, sodium, potassium, rubidium, cesium, francium. Now the challenge comes is that if I look at this group, everybody's valence electron is 1. अब इन दोनों में कैसे पता चलेगा who is more reactive? If I compare them with their bajuwala, so who is their bajuwala? Lithium, you have got beryllium. Sodium, you have got magnesium. Potassium, you have got calcium. It's very easy for me to compare between these two. Who is more reactive? This is more reactive. Who is more reactive? This is more reactive. Who is more? But what about this? Because sir, you said that they have got 1 as valence electron. They are highly reactive. Understood. But all of them have got 1. That is what we will study in this chapter. Have you understood? So the valence electron is a big measure for us, or in other sense, this valence electron gives rise to a concept which is written in your book called the ionic charge. Means if it forms an ion, what is the charge? Like say sodium. Sodium will always try to become an ion with 1 positive and lose 1 electron. Whereas if you look at magnesium, it will try to lose 2 electrons and become magnesium 2 plus. So the ionic charge on sodium is 1. The ionic charge on magnesium is plus 2. Which is a more reactive species? The plus 1 is a more reactive species. क्योंकि इसका जल्दी जल्दी हो जाएगा. It's despo एकदम. Very reactive. Is this thing clear? Okay. So if you look at the metals, if you look at the metals in the periodic table, the metals will all have positive ionic charge. In fact, we use this word many times that metals always lose their electrons, and that's why metals will be displaying electropositive valency. What is the valency of sodium? 1. It's a electropositive. Sodium's valency is 1. Sir, chlorine's valency is also 1. Yes, chlorine's 1 is a electronegative because it wants to gain, it wants to lose. This is electropositive. Have we understood this thing? Okay, right, very nice. Now the next thing that we need to understand is what happens as you are going slowly from metal, you come to a stage which is not a direct demarcation, but a staircase type demarcation where we get the metalloids. What are metalloids? Well, the metalloids will neither be good conductors nor be bad conductors, but they are semiconductors. They are midway between the properties of metals and non-metals. And after that, the non-metals start. Okay? And then comes to the inert gases. So we understand now what is a main group element. We understand what is a metalloid. We understand what is a metal. Okay, few more things. If we look at group 1. Group 1. The group 1 are said to be the alkali metals. Alkali metals, and they are very reactive. So reactive that majority of them are kept under kerosene and oil. Otherwise, even if they come in contact with moisture, sodium, if you just take it out, immediately it will start burning. And not only burning, it will vigorously burn. फटास करके जलना शुरू हो जाएगा, ठीक है? So in group 1, we have the alkali metals. Now, do you understand? And be very frank with me to answer me, okay? Do not hide anything. Do you understand what is the meaning of the word alkali? Because if you don't understand, you'll just not. Do you understand what is alkali? What is an alkali? Then what is the difference between alkali and a base? Quickly, ठीक है? यही सब clear करना है. Yes, soluble base. So whenever you have a metal will always react with water, and it will form something which is known as a metal hydroxide. Metal hydroxide. समझ में आया आपको? Metal hydroxide means it will be, if M is a metal and you are reacting it with water, it will be forming something called MOH. It is metal hydroxide. Okay, little bit. एक चीज गड़बड़ हो गया. 1 minute, हाँ. Metal hydroxide से नहीं देखेंगे. 1 minute, sorry. If you have a metal and you react it with oxygen, then it will form a metal oxide. We call it metal oxide. Metal oxides are always considered to be basic in nature. They are basic. This metal oxide will we will react with water, and this will form metal hydroxide. So this is known as metal hydroxide. This metal hydroxide can be water soluble or water insoluble. If you are water soluble, only then I call you as an alkali. And it's the alkalis that will show the litmus paper test. That also you should know, because these will keep on haunting you. And alkali kya hai? Alkali banai kali. So alkali will turn red litmus to blue. This is your test for alkali. A metal reacts with oxygen to form metal oxide. Metal oxide further reacts with water to form metal hydroxide. Metal hydroxide is typically known as your base. Bases which are water soluble are called alkali, which means all alkali are base, but all base need not be alkali. Are we clear on this? Similarly, iska non-metal story bhi sun lo. Non-metals react with oxygen to form non-metal oxides. Non-metal oxides, जैसे इसको हम क्या बोलते हैं? Basic. Non-metal oxides are either acidic or neutral. When they react with water, the acidic oxides form acids. चलो वो भी लिख लो, ये सब जरूरी है. Non-metal oxide, sorry, but this we have covered once. Non-metal reacts with oxygen to form non-metal oxide. A non-metal oxide can be either acidic or can be neutral. Acidic में कौन आ गया? जैसे कॉक्स आ गया, सॉक्स आ गया, नॉक्स आ गया. Means oxides of sulfur, oxides of carbon, oxides of nitrogen. Neutral you drink every day. Dihydrogen oxide. This is a non-metallic oxide of hydrogen. Neutral, that's why you're drinking it every day. Right? These when further react with water will give you acids like carbonic acid H2CO3, sulfuric acid H2SO4, nitric acid HNO3. So these are all my acids. Non-metals are usually acidic. Metals are basic. Those bases which are water soluble are known as alkali. And in litmus paper, what will they do? They will turn blue to red. So this one. Any doubt with anyone on this concept? Clear? Yes, ये रखिए, ये हर चैप्टर में हॉन्ट करता रहेगा आपको. ठीक है? So these are known as alkali metals. Group 1 are known as alkali. That means they are very reactive and they all will form alkali. That means they all will show the property of, then they'll ask you some question. Say, Cambridge is very fine in asking this question, that there is a compound and there is a hydroxide which has been formed from a group 1. How do you justify that it is an alkali? So you say that it is water soluble, then they will tell you, how do you know it's water soluble? That alkali, if you try to bring a red litmus, it will turn into blue. That is the key word. So if it is an alkali, it will turn all red litmus to blue. In fact, some of the wonderful alkalis are sodium hydroxide. This is known as king of base, and potassium hydroxide. Sodium hydroxide, potassium hydroxide. They are very, very strong alkalis. And alkalis are as harmful as can be acids. We only think acids are harmful. No, alkali can be equally harmful. So group 1 से ही मिलता है आपको. और group 1 आप in your book you have group 1. Group 1 आप याद करना है तो like we don't show hydrogen ऐसे दिखते हैं देखो. ली, लीना की, रूबी से फ्रेंडशिप. लीना की रब से फरियाद, जो आप लिखना चाहो. लिथियम, सोडियम, पोटेशियम, रुबिडियम, सीजियम, फ्रेंडशिप. लीना की रूबी से फ्रेंडशिप. हम लोग इसको ऐसे पढ़ते थे because we used to have hydrogen also in group 1 ना. है लीना की रूबी से फ्रेंडशिप. So it's common. Right, let's go to the next one. So is the alkali part clear now? Group 1 alkali. Because in your chapter you will be studying more in detail alkalis, and group 7 that is halogen. So tell me children, I'm going to use some words. Do you understand them or not? You straight away stop me if you don't understand. Do you understand what is the modern periodic table? The modern periodic table is based on atomic numbers, where the periodic property is what? Atomic number is the periodic function. The periodic function is the properties of element repeat itself after regular intervals, and the atomic number is the periodic function. We arrange them everything in the name of atomic numbers. Okay. In Mendel's periodic table, how did we arrange it? We arranged it in the form of atomic masses. Then do you understand what is a group and a period? Are you absolutely familiar with what is a group and a period? Right, fine. Do you understand what is a metal, what is a non-metal, and what is a metalloid? Metals are placed on the left hand side. Metals lose electrons. Metals display electropositive valency. Non-metals are on the right hand side. They will gain electrons. They display electronegative valency. Metalloids are somewhat in between, neither good conductors nor good insulators, but their conductivity is midway, so they constitute what we call as semiconductors. Okay. Do you now understand the meaning of the word main group elements? Main group elements are the elements which are from group 1 to group 8. Transition elements are not counted in main group elements. We are not going to study transition elements now. Sir, where are the transition elements located? They are located between group 2 and group 3, and they start from period number 4. They start from period number 4. So period 1, you have got 2 elements, hydrogen, helium. Okay. और period 2 से 8 elements आना शुरू हो जाता है. Okay, transitions are known. Now, so I think we have discussed a little bit about alkali. We'll discuss them again in detail. Alkali. Then we discussed about the transition metals. अच्छा, transition metals का खासियत क्या है? Your book doesn't touch. थोड़ा सा जान लेते हैं. Transition metals will be there between group 2 and group 3. You know. Now let's look at valency. If I ask you what is the valency of sodium, what do you say the valency of sodium is? Sodium shows +1, so the valency of sodium is 1. In transition metals, when you go to higher classes, you will understand that there is an orbital called d orbital which starts filling up. And these transition metals will show variable valencies. Variable valency. Not in your syllabus, just jaan ke rakho. Like say copper. Sodium is always sodium Na plus. Copper will display Cu plus, Cu2 plus. Manganese, 7 type of valencies it will display. Iron, Fe2 plus, Fe3 plus. That's the beauty in transition. And they start from period number 4. Period number 4. Okay? Okay. A little bit more discussion on, so if I talk to you about groups now, that's the knowledge that you have. All you know is that I have groups which are groups 1 to 8, and the first thing that I get from group is whatever is the group number is basically the valence electron count. Children, have you understood this or not? Right? So baat aata hai, sir, do you have any such correlation with period? Well, I would say whatever is the period is the shell number. Let's understand. Let's say we take period 1. Period 1, we have got hydrogen and we have got helium. Atomic number 1, atomic number 2. How many electrons in hydrogen? 1 electron. How many electrons in helium? 2 electrons. So which shell will get filled up? First shell. First shell filled up. If we come to period 2, lithium, beryllium, we have got boron, carbon, nitrogen, oxygen, fluorine, and neon. So if lithium, we say 3, 4, 5, 6, 7, 8, 9, 10. So if you see the electronic configuration, 2 are already gone. So it's 2, 1. See, period 2 means it's always shell number 2. So in shell 2, the first electron, उसी shell में हो रहा है. 2 electron, 3 electron, 4 electron, 5, 6, 7, and 8. Shell 2 complete. If you come to period 3, which shell are you opening up? Shell number 3. So period tells me what is my shell count. जैसे जैसे period बढ़ता जा रहा है, what is increasing? Number of shells are increasing. 1 shell, period 1, period 2, 2 shell, period 3, 3 shell, 4 shell, 5 shell, 6 shell, it's like that. So you may say, sir, you mean to say that if you go down the period, is the size increasing? Well, we will discuss about that. We will discuss about that. We'll discuss about that, because sir is saying that if I look down at group 1, just look at group 1 again, lithium, sodium, potassium, rubidium, cesium, and francium. So lithium has got how many shell, beta? 2 shell. Sodium has got 3, potassium has got 4 shell. That means number of shells are increasing. So don't you think the cocoon is increasing? Yes. बाद में बात करेंगे. There are some interesting things out here. Okay. So have you understood what does group and period say? Group देखते ही we will all get to know. Okay. One more interesting thing. Since the group tells you about the valence electron count, and if I look at group 1, my valence electron count is 1. It means that the chemical reactivity nature of all these will be similar. All of them want to lose 1 electron. In group 2, don't compare group 2 with group 1. Compare group 2 with everyone in group 2. Their chemical reactivity will be same. Therefore, it is always the valence electrons that determine your chemical reactivity nature. How strong, how weak, or how stable you are. Isme 1 hai na, everyone is 1, see. So if you know this one's chemical nature, what is the chemical nature of sodium? I know that, sir, a sodium will always link with a halogen. Halogen is who? Group 7. Let me take one halogen, say chlorine. A chlorine le lete. Chlorine is N. Can you predict the compound of sodium with chlorine? Sir, I can predict it. It is NaCl. Very good. Can you predict the compound of sodium with lithium? Yes, LiCl. Can you predict the compound of sodium with potassium? Yes, sir, KCl. Why is it not K2Cl? Why, sir? All of them have got 1 electron. If he alone goes and marries chlorine, this one will also alone go and marry chlorine. Na? एक ही तो electron है. Okay, let's go to group 2. Group 2, beryllium chloride, BeCl2. What should be magnesium chloride? MgCl2. What should be calcium chloride? CaCl2. Let's go to group 3, boron chloride, BCl3. What should be aluminum chloride? AlCl3. Now, are you understanding? एक को predict करने से आप दूसरे का compound. This is what Mendeleev used to do also. So have we understood a little bit about group? What does the group tell us? What is the significance of the group number? What is the significance of group number? The group number tells me what is the valence electron count. The group number tells me about the valence electron count of all elements in the group. In a summary, it is also trying to tell me what is the chemical reactivity, what is the type of compound every element in that group is going to form with a single particular element. And an example we saw that if you take one halogen, which is chlorine, if sodium forms NaCl, potassium will also form KCl. Clear? So, बहुत अच्छा. Alkali metals हो गया. Yes, sir. Any discussion at this phase?
Chemistry worksheet have a sign. Can you discuss those?
Yeah, why not?
Okay.
इतना clear हो आपको? Okay. Now we come to position of hydrogen. Okay. This is one of the ambiguity in the modern periodic table, position of hydrogen. While if you print a periodic table from Google, you might see that hydrogen has been placed in group 1, but the proper periodic tables do not place hydrogen either in group 1 or somewhere. Let's see. So what is the controversy with hydrogen? Hydrogen can actually fit in two different groups. One is group 7 and one is group 1. Let's see why. Group 7 and group 1. Let us see the things. What is group 7? Beta, group 7 are the elements which are the halogens. Halogens. Who all are there in group 7? Sir, fluorine, then chlorine, then sir, bromine. Their valence electron dekhte hain, to what is their valence electron? Their valence electron is 7. Means all of them will be forming negative anion with 111, right? Hydrogen is a gas. They are also gas. So looks like we should put hydrogen out here. Whereas what are they? They are all metals. And let us look at them. Lithium, sodium, potassium, all will be forming plus plus plus. Now the unique thing about hydrogen is that hydrogen के पास एक ही electron है. Okay, hydrogen has got one electron. So there is a possibility that hydrogen can gain an electron or hydrogen can lose an electron. If hydrogen gains an electron, then hydrogen becomes H minus. If hydrogen gains an electron, it becomes H minus for some time. And if hydrogen loses an electron, hydrogen becomes H plus. Whereas if you look at these two, ये कभी भी electron gain नहीं करेगा, ये कभी भी electron lose नहीं करेगा. Are you understanding? Hydrogen can have both. Now let us understand. Does hydrogen gain an electron? Oh, why not? If you see H2O, H2O is a covalent bond where there is oxygen. It has one bond with hydrogen on this side, one bond. So hydrogen is gaining one electron from oxygen this side and one electron this side. So hydrogen does gain electron. Gain करने से तो minus हो जाएगा ना? Fine. Does hydrogen lose an electron? Let's look at an acid, HCl. If we take aqueous of this acid, it becomes H plus plus Cl minus. The entire study of acidity is on your ability to lose H plus. What are acids? Acids are the compound which lose H plus. So one thing is very clear with us, H plus बनता है क्या? जरूर बनता है, जरूर बनता है. अगर H plus नहीं बनता होगा तो दुनिया में एसिड ही नहीं है. All acids are from H plus. But if you think about H plus, what is H plus? Isn't H plus a proton? Yes, hydrogen has got one proton and one electron. If it loses its one electron, it becomes a proton. That's why in higher classes, these steps are known as protonation. Protonation. Protonation means whenever you are trying to create acidity, you are bringing protonation. That H plus. What does not happen is that while hydrogen can gain to form a molecule, hydrogen can never lose and form a molecule. ये नहीं हो सकता. Show me one molecule where hydrogen has lost and formed a compound. नहीं होता है. Hydrogen can only lose to show an acidic behavior. Hydrogen, there is no compound. Because if hydrogen loses its electron and starts participating in a compound, then it is no more an atom. It is only a proton. This is one more challenge with hydrogen. So while the pluses, minuses make us that we should put it here, the pluses also have a controversy, then why not here? Are you understanding? First thing, hydrogen is a gas. So let us put it in group 1. Hydrogen's valence electron is 1. Sorry, hydrogen is a gas, so let us put it in group 7. No, hydrogen's valence electron is 1. Put it in group 1. Oh, sir, hydrogen gains electron. They also gain one electron. Put it here. Who says hydrogen loses one electron also in acids and form H plus out here? These are the controversies with hydrogen. As a result, the good periodic tables do not classify hydrogen either in plus, what is group 1 or in group 7, but they show hydrogen separately. Clear hai ye? What are the contests that you can see? This question can come up in any form. Why is hydrogen not classified? While your school might just ask you why is hydrogen not classified in period 1? In Cambridge, they will give you experimental type questions. Remember, hydrogen has got one valence electron, so it can very much come in group 1. However, hydrogen also gains one electron, so it can come in group 2. Hydrogen is a gas in nature, so it can come in group 2. Hydrogen loses an electron also, so it can come in group 1. बहुत झमेला है, इसके लिए इसको अलग ही रख दिया. Are we fine on this now? Okay. Now, some more questions. Metalloid and a semi-metal. Do you understand what is a metalloid? All of you. If there is any doubt, let me know. Do you understand what is a metal? Metalloid. A metalloid is somebody who is neither a metal nor a non-metal. Its properties are in between or intermediate. They form semiconductors. Next, do you understand what is main group elements? Yes. Do you understand what is transition elements? Transition elements are the metals which are between group 2 and group 3. Starts from period number 4. Alkali metals, group 1 metals are known as alkali. You know the name of group 2. Group 2 अगर आप लिखना चाहते हैं, group 2 is known as, book doesn't write but you can write. Group 2 is known as alkali earth metals. Means these will also form alkalis, but they can be mined from the crust of the earth. Earth के crust में मिलते हैं. Periodic property, a property of elements that shows a repeating pattern after regular intervals. Okay, so you know periodic property also. Let's now go to that size. Noble gases, I think you know noble gases. Relationship between group number and ionic charge. Whatever is your group number, that will be your ionic charge. However, mind you, for group 1, 2, 3, your ionic charge will be +1, +2, +3. Group 4, nothing like that because they share. 5 onwards, what do we see? -3, -2, -1, and once you come to noble gases, 0. Have you understood why -3? Nitrogen has got 5 electrons, so it needs 3 more. So that's also understood. Now let's get up to some interesting observations. Okay, let's get up to some interesting observations, and let's take group 1 now. Group 1. What is group 1? Sir, group 1s are metals. Okay, good. Sir, what about their valence electron? Valence electron is 1. Okay, very good. What about their, sir, valency? Sir, their valency is 1. What about their reactive nature? Sir, very reactive. Very reactive. Because valency is 1. 1 मतलब जल्दी से निपट जाएगा. एकदम desperate है. But sir, let's look at the group now. Lithium, sodium, potassium, cesium, rubidium. उल्टा हो गया. Rubidium, cesium, francium. Now, sir, amongst them, what about say about reactivity? Have you understood? Group 1 is very reactive. When I say that word, I'm actually talking about it from the perspective of group 1 versus group 2. But between them, sir, grade 9 is very naughty. 9A, 9B, 9C, 9D, 9E. इनमें कौन naughty है? Question is that. Now let's understand. So do you understand what is the property? What guides you to be reactive? ध्रुव बोल तो किसी को reactive बोले तो कैसे पहचानने का? Like अगर मैं अभी देखो इनमें के बीच में reactive कौन है वो ढूंढना है हमें. कौन ज्यादा reactive, कौन ज्यादा कम. बड़ा मन से सुनिए ये. Okay. अगर मैं बोलूं कि आप reactive हो, तो it cannot be a subjective statement ना. There should be some evidence. What is the evidence towards reactivity? I've spoken a lot about it today. What is the evidence? What property tells you that you are reactive? See, you go to a restaurant and you say they serve good food. When you order on Zomato between 2 restaurants, what do you see? You see how many stars are there. You have to have a measurable what? Quantity. Anything that gets measured can be improved. Food is tasty. What is taste to you? Subjective. So what do we see? We see the stars. In Amazon, when we buy about something, we see how many customer, 4-star, 3-star, that. So something measurable. So when you say about reactivity, first try to hunt what is that measurable property out here. Valence electron. Okay. Then valence electron means 1. What about that 1? अपने पास रखेगा, किसी से छीनेगा, छोड़ देगा। वन तो समझ में आया। वन के साथ क्या करना है? टू बी रिएक्टिव, let it go. Very good. So if you are talking about very reactive, in group 1 we are talking about that one valence electron. I'm sure ये आपको कोई ऐसे नहीं बताया होगा, and you are looking for how easily do you let it go. Well, if you can answer this question, then you understand who is reactive. Okay, now question arises, easily, not that easily. अभी समझ में आ रहा है ना? अगर easily छोड़ दोगे, are you reactive or non-reactive? You are reactive. That means जो easily छोड़ेगा, he is more reactive as compared to this one is less reactive. But please understand, when compared with group 2, this fellow is always more reactive. Within his group, he may be less. So now what we are trying to hunt, कौन easily अपना इलेक्ट्रॉन छोड़ देगा, right? So let's take a common study between sodium, lithium. Lithium में कितने shells है बेटा? 2 shells. Agreed? And valence electron means outermost electron. Where is the outermost electron? Out here. Okay. How many protons in lithium, beta? 3 protons. Correct. 3 plus. 3 plus. 3 plus. And I'm not drawing the 2 out here. There are 2 electrons in the first shell also. चलो एक बार draw कर देता हूँ. But these are not our interest. There are 2 electrons. This is lithium. Lithium से थोड़ा और नीचे चलते हैं. And let's take up one more. Let's say we take rubidium तक चलते हैं, cesium तक चलते हैं. Cesium. Cesium में कितने होंगे? This is 2 shell. This is in period 2. This is in period 2. So 2 shell, 3 shell, 4 shell, 5 shell, 6 shell. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6 shell. Okay. Where is the valence electron? Out here. I'm right now not knowing the atomic number of cesium. Okay, if I want to look at the atomic number of cesium, so let's take cesium. Its atomic number is 55. Okay, cesium is 55. So how many protons for cesium, Srinika? 55 protons. 3 protons. Our study is how quick will this electron get lost out or will get loose. Now, one thing you might see here, that a 3 unit positive charge is having a control on 1 electron. This is the electron. Negative hai. Positives attract negative. So this one is very close to its nucleus. Here, so it's like 3 policemen keeping a watch on 1 electron. जाएगा, इतना आसानी से नहीं जाएगा. Whereas if you see here, there are 55 policemen. So you might think, sir, we have increased the security. So the surveillance on this little tiny fellow who is rotating should be much more. 55 positive forces are holding this. But there is a catch here. That catch we call is all these shells which are coming in between. This is a little bit high level, but this will make you understand. This is called shielding effect. If I want to hit you in Pebble City, we are both in the same grade and class, and I want to hit you, but your mom keeps a good surveillance on you, I will always try to hit you when you're farthest away from your mom and your mom can't see you. Shielding effect. No matter how strong your mom can be in the balcony, but मैं तो आपको यहाँ पीट सकता हूँ, यहाँ नहीं. Are you understanding? The shielding effect overpowers this 55 electrons which have come up here. As a result, now you tell me, whose electron will be lost more easily? Cesium's electron will be lost more easily. Therefore, we say that the metal's reactivity increases as you go down the group. This is high and this is low. ये लॉजिक आपको समझ में आया? अगर आपका रिएक्टिविटी हाई होना है तो ये इलेक्ट्रॉन इजीली जाना चाहिए. You might say, sir, this electron is under the influence of so much of positive charges. Why will it get lost? These positive charges are of no use. It's like our fellow Dhruv has brought a very good router. His laptop is here. But what did Kirtan do? He introduced a lot of concrete walls in between. Ja beta, ab Wi-Fi browse karke dekh. Now can you browse Wi-Fi? Sir, router is very strong. But at Kirtan's house, he has got a medium class router, but just one curtain in between the router and the laptop. Aram se browse kar. Do you understand what is shielding effect now? Shielding effect is very powerful, and shielding effect does not allow you overpowers this. So what about the reactivity? The reactivity goes. Okay. Now next thing, let us talk about, we have spoken about reactive. Let's look about the size. Size of the atom. जरा size के बारे में बात करें तो. So what do you see here? Slowly the number of shells are increasing. So don't you think the size should increase? Yes. So as you go down the group, the size is also increasing. Yes, the number of shells बढ़ता जा रहा है ना. Right. If you go down the group, is the atomic mass increasing? Oh yes, why not? 3 protons and these are 55 protons. And let me give you a rough idea. An electron is only 1 by 1840 times a proton's mass. Electron तो कुछ है ही नहीं, हवा है. Proton is very, very heavy. Electron is almost negligible as compared to a proton. So if the mass increases, what about the density? नीचे जितना जा रहा है भारी होता जा रहा है. So the density should increase, right? So generally we will also see size increases, density should increase. This is overall for the periodic table, okay? But there will be some variations also. Density should increase. Then what about the melting point and boiling point? भारी भारी चीज हो रहा है तो वो सब भी increase होगा, है ना? A small piece of potato which is cut like the dice of a board Ludo game, that potato will just boil immediately. इतना भारी आलू देंगे तो boil होने में time लगेगा ना. So the melting point, boiling point all increases. But don't take this reactivity. This reactivity we are talking, this is only for metals. इसे metals के लिए देख रहे हैं हम reactivity, not for others. Okay. So which element should be the most reactive here? Francium. Francium should be reactive, but the problem with francium is radioactive. Radioactive का मतलब क्या है? Francium will decay very quickly, and franciums, there's a thing called half-life that I'll tell you. Half-life is approximately 5 minutes. What do you mean by half-life? Half-life means, a very easy example, 5 minutes half-life means, have you understood? If you open a odonyl packet, odonyl goes on vaporizing. So half-life 5 minutes means if the odonyl was 50 grams, 5 minutes में 25 ग्राम हो जाएगा. Francium's half-life is very, very fast. Every radioactive element has something called half-life. Half-life is the time taken to decay half your original amount. So if I give you 1 kilo francium, 5 minutes में half kilo हो जाएगा. Next half minute में कितना हो जाएगा? Half of that, 250 grams हो जाएगा. Next 250 का half, 125. Half-life is like that. We'll study that in radioactivity. So we say cesium is very reactive because francium के साथ आपको खेलने का time ही नहीं मिलता है. Concept understood, बच्चा?
Yes.
Very good. एक और देखते हैं अभी. Let's see. Now let's see the halogen family. Let's see the halogen family. Okay. Interesting again. The halogen has got fluorine, chlorine, bromine, iodine. इसके नीचे astenine है, that is again reactive. So we will speak about these only. Fluorine, chlorine, bromine, iodine. Okay. Fluorine comes from period 2. This is at period 3, period 4, period 5. So, okay. Let's talk about the valencies now. Let's talk about the valency. We are at group number 7. So our valency is again 1, but our valence electron is equal to what? Beta, what? 7. They are very reactive. Now come and answer me the same question. What is the property that makes you understand reactivity? Valency. Valency for one electron. But this valency is what? This is a electronegative valency. Electronegative means gain. Gain. Their valence is 1. They are not like group 1. Group 1 को lose करने का था. इनको gain करने का है. So how do you now define reactivity for them? There, what did you say? How easily do you lose? No, not how easily do you gain. How ferociously do you gain? You are a gainer. डकैत हो आप अभी. So bring that feeling in you. How fierce are you to snatch is the better word I'm using. How fierce are you to snatch? The more fierce are you, the more you will be. If you are more fierce, then you will be actually pulling that electron quickly and you will be said to be more reactive. Fine. Now let's see. Okay. Now if you look at fluorine, fluorine has got 1 shell, 2 shell. And if I look at iodine, iodine has got 1, 2, 3, 4, 5 shells. By the time, so this is the electron which is available freely outside. Now it is your call to kidnap this electron. One who kidnaps this electron faster is a more reactive species. All of them are reactive, but between them, who is more reactive? Now, how will this electron be pulled? Just imagine. The electron has to be pulled by the positive charge present in the nucleus, right? So we have a lot of, if I look at iodine, so let me look at iodine. Yeah, iodine is 53. So iodine is 53. So I have got 53 positive charges. Whereas if I look at fluorine, okay, fluorine is what? 2, 7. That means 9. So we have got 9 positives out here. 9 positives trying to pull this electron. 53 positives trying to pull this electron. Your immediate heart will say they will win the battle. But the Kirtan has put a lot of concrete layers in between. Shielding effect comes into play out here. And not only shielding effect, it's a joint family where the 3 elder brothers are already married. And pardon me for making this remark, don't tell me male chauvinist. The younger brother is now getting married and the youngest Bahu is coming. Do you think the other 3 Bahus will let her settle so easily in the house? Not easy, generally. There are so many electrons out here in the outermost orbit. These electrons will tell him, don't come, don't come. But he's saying, hey, come. I can't hear you. There's a lot of audibility problem. And these are saying, don't come. Have you understood this? Chemistry is the literature of science. You have to understand it with language and literature. Out here, what is happening? ये बड़ा भाई के बाद 10 भाई शादी हो रहा है. आओ आओ देवरानी अंदर आइए, please come. The call is also heard very nicely because you are very near to the nucleus. So fluorine, in fact, is considered to be the most electronegative element. Most electronegative means फटाक से खींच लेता है. So यहाँ the pull will be much more. So here what we will see, the reactivity trend will show that as you go up the group, the reactivity increases. Is this logic understood? Why in group 1 you see the reactivity increasing down the group? Why do you see the reactivity increasing up the group? Anyone who has not understood, I can say again, but for God's sake, understand it properly. Why the reactivity increases when you go up the group? Because here, fluorine's affinity to catch that electron is far more as compared to iodine. And the story remains same. The shielding effect will play a lot of role. Okay. Have we understood this one? So non-metals are more reactive. Fluorine is most reactive. And, you know, now we have got a very debatable thing that we have to study here. Let's take this as grade 9. This is grade 9. And they have been labeled as naughty. They have been labeled as naughty. Okay? And we have said that this section is the naughtiest. Now you participate in this discussion. If this section is the naughtiest, what is about this section? What about this section? Least naughty. कुछ तो बोलो ना यार, मैं 1 घंटे से बात करता हूँ, कुछ नहीं बोलते हो. If this is the naughtiest, what is this section? Why can't be compared? I'm saying they are all naughty, and the trend of naughtiness increases upwards. Yeah. The trend of naughtiness increasing upwards. So this is least naughty.
Yes.
I will say another way. I will say the tendency to become good increases downwards. Can I not say that? A least naughty child is good as compared to a naughty child. अब समझ में आ रहा है? If you gain electrons very quickly, what do I call you? Non-metal. If you do not lose electrons so quickly, what do I call you? You're not a good non-metal. तो आप में क्या ट्रेंड दिखाई दे रहा है? Metallic trend is increasing. Your metallic trend is increasing. This is very, very confusing to understand. That's why I gave that example. Does not mean that this boy is good. Please understand. This section has been labeled naughty. He is not good. But if you compare them in naughtiness scale, the naughtiness scale increases. तो नीचे जाने से ये लोग naughty नहीं है, तो क्या है? अच्छा ही बढ़ रहा है इनमें. ये अच्छे नहीं हैं, इनमें अच्छा ही बढ़ रहा है. ये मेटल नहीं बन गए, पर इनमें मेटालिक कैरेक्टर ज्यादा दिख रहा है. इनमें मेटालिक कैरेक्टर ज्यादा दिख रहा है. Okay, little bit of humor. जैसे you see, what do you see? Nidhi, did you understand this? These are not metals under any day. Their non-metallic character is more sin. Who is the non-metal? Somebody who takes an electron. Who is a metal? Somebody who loses an electron. So you should say, sir, why did you not discuss this in the previous slide? Well, I should have also discussed this. I say that the metallic character increases downwards because I lose. So the non-metallic character increases upwards. So a little bit of humor in this. Okay, what is the humor? We have boys and girls. So you will see some girls who are who like to be tomboyish. You know what is tomboyish? That girl's collar will be थोड़ा ऊपर, sleeve ऐसे, ए हट जा, ले आएंगे तेरे पास, वो करके ये कर देंगे. वो लड़का नहीं बन गया है. उसके अंदर the male, what do you say, the property is more, we say. The property is more, right? Similarly, you will see some girls, मैं नहीं खाऊंगा. Some boys, जा मैं तो तेरे पास नहीं. वो उसके बातचीत में कैसा लड़कियां ना अंदाज आता है. He gets hurt, he says, ouch. Have you seen? There are some boys. Ja lucha, don't disturb me, I'll tell my mother. So we used to say, "Ye kya garli baat karte ho?" In fact, when you study biology, you will see that there are two hormones, testosterone and progesterone. It doesn't mean that testosterone is present only within the male group. No, it's there in the females also, and progesterone is present in males also. Males who have more count of progesterone will show this behavior. Hey, जहाँ ऐसे बात करेगा. And girls who have more of testosterone count will say, hey, come up. अब थोड़ा बुलेट चलाएगा. They won't drive Activa. They have that number. बाल शॉर्टकट रखेगा, हाथ में ऐसा बड़ा एक पहन लेगा. आए कैसे हो यार, ऐसे बात है. So ये वैसा ही है. इसका मतलब ये नहीं कि वो लड़की लड़का बन गया है. इसका metallic character increase होता है. Are we fine on this? Good. तो ये भी हमने सीख लिया. This. Okay. Now the next thing that we need to understand is, ये सब तो सर ग्रुप में आपने बात किया. Then we say, see, if you study in CBSE and all, the entire periodic table is studied like this. Down the group, and then we say across a period. But this is the way you study everything. Chemical reactivity, ionization potential, this. What happens down the group? What happens across the group period? Down the group and across a period. So let's study something called across a period. Let's take up, say, period number 2. P2 ले लेते हैं. P2 में कौन-कौन है? Lithium. उसके बाद beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Oxygen I have written 6. So fluorine I am missing basically. Fluorine is 7. Okay, and neon is 8. So let's not consider neon. Okay, we are ruling out neon because neon is inert gas. Now let's look about fluorine. So the idea was about fluorine. So fluorine has got 7 electrons, and fluorine's what is the atomic number? It should be 27. So it's 9. So in fluorine, I have got 9 positives doing a control on 7 electron, and here I have got 2 positives. Now you tell me where is the force more? Fluorine, the force is more. If you compare fluorine with oxygen, let's say with oxygen, okay, oxygen has also got 2 shells. I have got 6 electrons, and in oxygen, how many I have? 8 protons I have got. 8 protons pulling 6, 9 pulling 7. Along a period or across a period as you go, the nuclear positive charge increases. Electrons are added in the same shell. Shells don't increase. Therefore, there is no question of shielding effect. Your central charge is increasing, so the central charge has got more control on the outermost electrons. They pull them. As a result, you will see that the sizes are starting to shrink. वो shrink कर जाएगा. This is a very nice observation. If you move across a period, the atomic size decreases. Have you understood this thing? Or you want one more round of explanation? If you want, you tell me, there is no issue. One more round across a period, okay? Across a period, let's say. Don't look at the watch because we can't be so much watch oriented करके नहीं पढ़ा सकते. Across a period. Let's say what happens across a period. Tell me, number 1, shell count remains same. When positive charge at nucleus adds up. And 3, electron gets added in valence shell. These two actually contribute to more nuclear force of attraction. Attraction on valence shell. Have you understood? जैसे जैसे पॉजिटिव चार्ज बढ़ता जा रहा है, आउटर चार्ज भी बढ़ रहा है, and the force, because this nuclear force is directly proportional to the product of the charges Q1, Q2. This you'll learn in higher grade. But more are the charges, more is the nuclear force. So more nuclear force means what happens? The radius shrinks. खाली पैराग्राफ पढ़ा के तो एक दिन में पढ़ा सकते हैं, उसमें मजा क्या आएगा? Radius shrinks. So what do we say? Atomic size. If you look at atomic size, then the atomic size is always in this manner. This is the atomic size across a period. This side you will get bigger atoms. That side you will get smaller. Why you get bigger atoms out here? Lithium, 3 on 1. And as I said, fluorine, 9 on 7. Much more stronger. Because the nuclear force of attraction is directly proportional to the product of the two charges, inversely proportional to square of the distance. Less is the distance, more is the force. More is the charge, more is the force. Charge ज़्यादा उस side है इसलिए. But in the case of down a group, why did the size increase? The size increased because this force was weakened due to the shielding effect. So and every group, every step you come down in a period, when you come down the periods, period 1, 1 shell, the shell size is also increasing. So atoms become bigger and bigger. ठीक है, आज यहाँ रखते हैं.